Now moving on to something new, lifetimes. Lifetimes exist to solve one problem, making sure a reference never outlives the data it points to. This prevents dangling references. At compile time, Rust guarantees no reference ever points to freed memory. It's usually inferred. In most code you write, the compiler figures out lifetimes automatically via Elysian rules. You don't write them. Explicit annotation required. When returning references tied to inputs and the relationship is ambiguous, the compiler needs your help. Lifetimes are not types, they are generics. Annotation like these describe relationships between references. They don't change how long data lives, they just explain it to the compiler. Now let's see it in code. We have the following function longest. It takes in 2 string slice in the parameter and it returns a string slice. This won't compile because the compiler sees 2 input references and 1 output reference and can't determine which input the output is tied to. You need to tell it. So how do you do it? We use that annotation that I mentioned. So let's do that. So what we do is we go to a parameter. Here we use the annotation, this annotation, and we also do it inside the parameter. And here okay, so now it's going to compile. You can say it's returning hello as expected. Now let's just go back to the way it was and see what's going to be printed out. Let's see, because we know it's not going to compile, but we want to see the error messages. So here's the missing a lifetime specifier. It expected name lifetime parameter. So they give us an example on how we can use it here. This is a lifetime parameter. It says the output reference is valid for at least as long as both inputs are valid. The compiler now knows the return reference can't outlive either input, and this is safe to use. And pro tip, lifetimes don't change how long data lives, they just explain the relationships to the compiler. Now let's look at different code on the main. Inside the inner scope, both S1 and S2 are alive. So we have S1 here and S2. It's alive here in the scope. But after the inner scope closes, S2 is dropped. So here if we print result, we'll be able to catch both S1 and S2 since they're still alive. But printing out result here, S1 will be dropped. S2 will be dropped. Let's see it in action. So here we're going to print long string because we're printing the first string on the parameter. We can also print s2 since it's still alive here, so let's do that. You can see we printed S2. So inside the inner scope, both S1 and S2 are alive. Using result is valid, but after the inner scope closes, S2 is dropped. So printing result here outside will be a dangling reference. The borrow checker catches this at compile time. So because the lifetime of result is tied to the shortest input, S2, it cannot outlive S2. Lifetimes can also be used in struct. So here's an example. If a struct holds a reference, it needs a lifetime annotation to guarantee the reference remains valid as long as the struct exists. Here, looking here, it says the struct cannot outlive the string it borrows. Excerpt goes out of scope before novel. The compiler verifies this. Here's a concept, new concept. If a struct holds a reference, annotate it with a lifetime like this to guarantee the reference remains valid.